So we're going to start the lesson off by learning law of sines, okay? But before we learn law of sines, the main question that stands is how can I solve missing sides and angles of oblique triangles? Well, first we got to learn the definition of an oblique triangle. An oblique triangle is a triangle with no right angle. Previously, you learned how to solve right triangles with a squared plus b squared equals c squared. Well, with law of sines, you're going to learn a little bit differently, okay? And now we're going to get into law of sines. Okay, so we're going to be learning about the law of sines, and here's some more background information. So the law of sines can be used to find sides and angles of oblique triangles. Previously, you learned how to find sides and angles of right triangles, but now we're going to learn how to find it for oblique triangles. So to find missing sides of an oblique triangle, you're going to have side and angle measures given two angles in any side. This can be seen through angle, angle, side, okay? Angle, angle, side, or angle, side, angle. Okay? The next situation is we're finding missing angles, okay? Two side lengths and an angle outside of them. This can be seen as side, side, angle. Next, we're about to learn the law of sines formula. Okay, now we're going to be learning about the formula for law of sines, okay? But before we learn about the formula, we're going to learn about why. Why does the formula exist? And this is a little bit of background information so you don't get confused with the numbers and letters. Okay, so in a triangle, we all know a triangle equals 180 degrees, okay? In this particular triangle, we have three set angles. We have angle A, angle B, angle C. Given angle A, B, and C. Okay, now we're going to learn about the sides, which are the lowercase letters. We have A, B, C. Now, you're probably wondering why is angle A opposite of side A opposite of angle A. And this is because of SOHCAHTOA. SOHCAHTOA states that sine equals opposite over hypotenuse. Well, this is opposite, and this is technically our hypotenuse. So opposite over hypotenuse. So that's where we get into the formula. We have sine capital A, which is the angle, over lowercase a, equals sine capital B over little b, equals sine capital C over little c. Or you can always rewrite it as A over sine A, B over sine B, equals C over sine C. Now, sometimes this one is used to find sides, and this one is used to find angles. But you can intertwine them, it doesn't really matter. Usually, I personally use this one right here, because it's a lot simpler, you just stick with one. Another thing is, when using it, make sure that you remember that the big capital letters are angles, and the lowercase letters are side lengths. Okay, so we're still talking about the law of sines. But now we're going to learn about finding angles a little bit more in depth because this one has an ambiguous case. So we always have to watch out. When finding angles, it's possible to have one solution, two solutions, or no solution. Okay, no solution is called the ambiguous case, okay? You're going to do that on your own. You're going to figure that out on your own. But we're going to learn about some important facts. So the sine function has a range between -1 and 1. And you might ask why. Well, on the y-axis, think about it. We have pi over 2, 3 pi over 2. Well, the sine of pi over 2 is 1, okay? And the sine value of 3 pi over 2 is -1. So that's how you know the range is between -1 and 1, okay? Angles with a positive sine function value can lie in quadrant 1 and 2. Okay, this is because values of y will always be positive above the x-axis. Okay, keep that in mind. Okay, the sum of the angle measures in a triangle is 180. Y'all already knew that, so that's just a little bit of review. Okay, now this is when we want to find the other possible angle. We're going to subtract it from 180. Okay, and no triangle can have two obtuse angles. And you might ask, why can it not have two obtuse angles? Well, this is because the angle sum of a triangle is 180 degrees, okay? Obtuse angles are 90 degrees to 180 degrees. If we add two together, their sum will be larger than 180. So let's say there's two obtuse angles. They're both 90. That 90 plus 90 is 180. There's no other possible way another angle can be an angle measure because that's already 180. And we know that the sum of a triangle is 180, okay? So that's just a little bit of background information about law of sines. I'll say the formula one more time. Sine A over little a equals sine B over little b equals sine C over little c, okay? You're going to practice on your own and dig some more information about law of sines and what you can figure out. Good luck.